I'm okay. I'll just ask them at the office to print me a list. Yeah. Excellent. Very good. Very good. Very good. Georgia. Geo. Is Geo here? Geo's here. Okay. Ravina. Ravina? No, Ravina. Charlene. Excellent. Chantal. Aaron. I thought I saw. No. Oh, right in front of me. That I thought I saw you, and then I lost you. Okay, and Nathan? No, Nathan. Okay, Nathan. Good stuff. And Lauren? Good. And Samuel? Yeah. Amy? Good. Tiana's here. Ben is here. Chloe is here. Silvana. Micah. Angela. Angela, right in front of me. Gotta learn that one. And Kylie's here. Francisco's here. Alden. Excellent. And Andrew is no longer with us. John. Desa is here. Jacob is here. Mandir is here. Stuart and Manning and Evan. Excellent. Everybody's here except Ravina. Except for Ravina's here now. You just weren't here a minute ago. It's all good. Okay. All right. How do we feel about accuracy and precision? I would like you to describe to your partner the difference between accuracy and precision. See if you can give an example. All right, so maybe one of you can tell accuracy, the other of you can tell precision. And if you don't have a partner, like Amy, maybe you can turn around and talk to Angela. So, would anyone like to share with me? Anyone feeling brave today would like to share the difference between accuracy and precision? No? Yes. Yes. The nice way to remember it is that accurate, okay, this is not a happy page, add a page. Accurate begins with ac, yes? And accurate is how close you are to the, guess what, the actual value. What if I gave you a bunch of different values and I said 7, 5, 18, 26, and I said, here is your data set. And I should have prepared this ahead of time, so I'm going to have to just do a quick little calculation here. Let's see. Does everyone know how to find an average? How would you find an average of those numbers? Add them all up and divide by 4. Okay, so let's say that the actual value was 32. Are those values precise? No. Why are they not precise? What does precision mean? They're very inconsistent with each other. If something is precise, there is consistency between the values. Precise has re in it. Okay, precise means that, there was a word here I was looking for. Oh, it's just slipped my mind. Repetition, thank you. I'm like, oh my God, where did it go? Repetition, so it means you get close repetition between the numbers. And in this case, is there close repetition? No, those numbers are like way far off each other, yes? And so we would say that those values are not precise. Are they accurate? Have a little chat about that. Discuss amongst yourselves. Feel free to use a calculator if you want to, if that might help you. And if you don't have a calculator, you can use your phone. So yeah, these results, what did we get when we calculated the average? Okay, so the average is 31.5. So you could say that looks pretty accurate. Yes, because it is close. If you're dealing with a data set, none of these individual results are accurate, but as a data set, it is accurate, but it is very imprecise. If you had data like that, you would probably say, I have some garbage data. I need to do some more experiments and take some more measurements to get something a little bit better. You want your results to be as accurate and precise as possible. When I was in university, second year, we did an analytical chemistry course. The lab portion of that course, we did a lot of things where you had to calculate concentrations. You did a lab and then figured it out. And you would figure it out by seeing when this thing turned color. Some of them were really easy to see. You would see it started out colorless and it would turn a lovely light pink. You will do this one this year. It's really easy to see when it changes color. However, there was one where it started out as a muddy green color, and when you were supposed to say, okay, this reaction is done, it turned to a muddy brown color. Okay, so this was really hard. I'm like, what color am I actually looking for? And my professor, he was not a nice man. He basically, I said, how do I know what color? He's like, I don't know, you find out. Like, I have never done this lab before. I've never seen it. This was back before you could Google everything and like see a color, you know, on the computer. And we got marked. Our lab was only marked on accuracy and precision. So what I would do is I would like, I don't know if I'm accurate because I don't know if the color is actually accurate. And I will say this is the only time I have ever cheated, okay? Only time ever, because he was such a doofus. There's another word with a D that I would like to use, but I'm not going to. He was a doofus. Because he was such a doofus, I took all my data and I squished it towards my average. So instead of having these numbers, right, I'd be like, okay, I don't know whether 31.5 is good, but I'm going to assume that's okay. And I would be like, okay, let's move this one when we'll make that 35 and we'll make that one 43. And I would just move everything a little bit closer to the average, which I am not really proud of. On the other hand, the guy was a major doofus, and so I felt a little bit justified in it. I have trouble with people who are just, you know, mean and nasty and not helpful. So anyway, yeah, there's a true story about accuracy and precision. All right. So today we're going to leave that for a little bit. We were talking last day about the SI units and prefixes. Do you remember the song? Okay, so let us, if you don't remember your SI units and prefixes, page 61. So the units, we have liters. What's next? Meters, moles, Kelvin, kilograms, and seconds. Liters, meters, moles, and Kelvin. Kilograms and seconds. We'll do it twice more. Liters, meters, moles, and Kelvin. Kilograms and seconds. Liters, meters, moles, and Kelvin. Kilograms and seconds. Are those quantities or are those units? These are all units. What is the quantity that goes along with liters? Volume. What's the abbreviation for volume? V. What is the quantity that goes along with meters? Lowercase d, distance, yes. How about moles? That's the tricky one. We didn't talk a lot about that. It's amount of matter. Yeah, and the reason I believe that they chose the letter N is that if you remember, a mole is, what is a mole? A mole is a number, okay? So we represent it by the letter N because it's a number, okay? And then we're back to Kelvin. What's the other unit we might use instead of Kelvin? Degrees Celsius. And it is represented, what quantity are we measuring? Temperature, which is lowercase or capital T? Capital. And then we have kilograms. What quantity are we measuring? Mass, lowercase m. And finally, oh, by the way, are these uppercase s's or lowercase s's for seconds? Lowercase s's, and that is our time. For some reason, in my grade 9 block, I could not figure out how to do my T like that. I kept going like this and going, that looks so wrong. But it, like, my brain just went weird for a minute. Anyway, so there we are. Okay, good. Do you remember your prefixes? So we're going to start from the biggest and go to the smallest. So we have mega, kilo, deci, centi, milli, micro, nano, and then your abbreviations are mega, kilo, deci, centi, milli. And then what's that letter? It's the weird U, it's that weird M, it's the letter mu, it's a Greek letter, Okay, so we have micro, and then we have nano. So really the only one that's weird is the micro. All the rest of them are just the first letter of the thing, and the big M is for the thing that is big. And if you want to learn how much they are right now, this is, if we write down tens beside them, it's 6, 3, 1, 2, 3, 6. 9 is for the nano. Mega, kilo, deci, centi, milli, micro, nano. 6, 3, 1, 2, 3, 6. 9 is for the nano. Now, you're thinking, this looks weird because this one is a 6 and this one is a 6. What's the difference? It's because at this point, once we get below kilo, these are all going to be negative. Okay? 6, 3, 1, 2, 3, 6. 9 is for the nano. Now, technically, you're not responsible for those powers of 10 until the next unit, but I'm introducing them now because what works as a study technique? Repetition. So we're getting that repetition in right now. Okay, you are responsible for knowing the prefixes and their abbreviations and which order they're in, just from biggest to smallest. And if you don't need to know this part yet, but like I said, I'm going to keep introducing things even though you're not going to be tested on it right this moment. Okay? So that's what we did last day and what you did for homework. Today we are going to, what are we going to do today? Ooh, we're going to make some measurements. So this is 1.4b, as in Bob. That's on page 65. And there is a video that goes along with this. I'm not going to play it, but if you are at home and you're thinking, I would like to go over this again, there's a very nice video that accompanies this that I got the images from. So for any measurement, the final digit is considered to be the uncertain, or you could say estimated digit. So you're not going to read this, you're not going to read this ruler and say, oh, this is 6.2489631 centimeters. Would that be a reasonable measurement from that ruler? No, absolutely not, because it's like, how on earth am I'm just making stuff up. Yeah, I'm making stuff up. It's wild and crazy here, okay? But we don't want to do that. We only want to make up one number, and we're not just making it up, we are making an educated guess as to that number. We are estimating that last digit. What is the one number that we know for sure from this ruler? We know the 6, so our length of our pencil is going to be 6. And now, this is a pretty lousy ruler. It doesn't have any other markings. What do you guys think that is? 6.1? Any other guesses? Could it be 6.2? Maybe. Somebody might say 6.2. It depends. You know, I've blown it up, but if you're, if it's a lot smaller, it might be harder to tell. So you could say 6.1 centimeters, or you could say 6.2 centimeters, and I could not fault you for either of those. Okay? These digits here are our uncertain digits. Our estimated digits. And that's where we have to stop, okay? So all of this garbage here, that's nonsense. Can't have that, okay? When you are recording a measurement, and you will be recording a lot of measurements for chemistry labs, you are going to write what you are measuring. So that would be the length of the pencil. You're never just going to write in the middle of nowhere on your page 6.1 centimeters and hope that I know what you're talking about. Okay, you're going to tell me, what is 6.1 centimeters? Well, that is the length of the pencil. You are going to write one and only one estimated digit, and that is going to be the final digit. And finally, no measurement is complete without units. Okay, units, hugely important. If you don't write a unit, it doesn't mean anything. Yeah, if I just write the length of the pencil equals 6.2, well, what if I've just chopped off a tiny little piece of my pencil and it's 6.2 millimeters? Or what if I have like some crazy novelty pencil, you know, where I can, you know, write with it like this and it's 6.2 feet long? You know, I mean, it's not likely. It could be 6.2 inches. That would be a reasonable sized pencil, I would think. You know, but you need to give me a unit so that I know what you're talking about there. So you need to know whether that centimeters or inches would probably be the only thing that would actually make sense there. But so what are the 3 things you need to write down when you are writing a measurement? Tell your partner, what are the 3 things? Don't look at your paper. Tell your partner, what are the 3 things to write down when you're writing down a measurement? Okay, are we feeling good about that? Yeah? Okay, so you should refer to this often when you're doing labs or recording measurements for, say, a quiz or something like that. You always want to have those 3 things. You will not get full credit if you don't include all of them. Okay? So if the object measured is, exactly on the, what is this one exactly on? It's exactly on the line. You need to add a, can anyone guess? 0 to the end. If you were just to write 6, and that was it, 6 would be your final digit, right? If you just had 6, it would be your first digit, it would be your last digit, it would be the only digit. If it's your final digit, what do we know about our final digit? Our final digit is always estimated. Okay, our final digit is always estimated. So if we were to write 6, that would mean that it could be 6 centimeters, or it could be 5 centimeters, or it could be 7 centimeters, because that 6 would have been estimated. And that's not the case here. Is anyone looking at this pencil and saying, ooh, maybe that's a 5 centimeter pencil? Maybe not, right? Okay, so this is definitely exactly on the 6. So we know for sure that our length of the pencil, remember to write that part down, is 6, and then we have to add a guess, 6.0 centimeters. Now, how do you know if you need to add that extra digit? Well, one way of doing that is saying each of these is 1 centimeter. Yes, 1 centimeter, 1 centimeter, 1 centimeter. Every line represents 1 centimeter. And that is in the ones position. So if we look at our positions next to the decimal, this is the one that we know for sure, right? Because that's the one where we have those lines. The ones position we know, we have to estimate one more than what is told to us by the lines. Does that make sense? So the lines are the ones that we know for sure, and then we estimate one more than the smallest little division on there. So if it measures ones, you can go to the tenths. If it measures tenths, what would you go to? Hundredths. If it measured hundredths, you would go to the thousandths. If it measured tens, you would go to the ones. It's always like 1/10 of the smallest division. Okay? Yeah. One more place value. Okay, let's see. What do you guys think about this particular pencil here? Yep, that's all we can do. We can say it's probably 6. Maybe it's 7. It depends on how good you are at estimating. Yes? So it could be 6 or 7. Could you say 6.5? We have estimated the 6. Yeah, and so if we did the 6.5, it would break the one estimate rule. So we've already estimated the 6. We cannot estimate a 5 after that. Does that make sense? Okay. This 6 right here is already estimated. We can't go past it. And we have that rule where you go to the number that is 1/10 of the smallest division. What are the lines worth on the ruler? 10 centimeters. So you are going to estimate to one position less than that. What's one position less than 10? 1. I feel like we've done this one already. Have we done this one already? Why do I have that twice? Oh, well, that's okay. We've done this one already, yes? No? Okay, never mind. I'm having like a brain glitch. Those are fairly common for me. I'm getting old, you know, it happens. So here we have this pencil. And what would we estimate its length? Tell your partner what you would estimate the length to be. Okay, I'm going to try and learn a few names here. I'll go to my back row. Ben, what do you think? Sorry? 6.7. Excellent. Did anyone come up with something different than 6.7? 6.8. Excellent. Both of those would get full credit, okay, as long as you wrote length of pencil equals. Could you say 6.75? No, because you already guessed at the 7 or the 8. The other way of looking at it, what is each ruler line worth on this ruler? Each ruler line is worth 1 centimeter. What is one place value less than 1? I feel like I'm not asking the right question. I feel like my vocabulary that I'm using is not the right vocabulary. So basically, when I talk about place value, we go from the, thousands. What's the next place value after the thousands? Hundreds. And then we have the tens, and then we have the ones, and then we have the 0.1s, and then we have the 0.01s. And so what this would look like then is we would have, if I'm just going to put zeros here, I would have a 0, 0, 0, 0, 0.0, 0. And I could throw any numbers in there. But this is the thousands position, this is the hundreds position, this is the tens, this is the ones, and then there's my decimal, and then there's the tenths and the hundredths. That's what I'm talking about when I'm talking about the place value. Does that make more sense? Yeah? Okay. I'm like, y'all are looking at me like I've grown 3 heads. This is a fairly simple concept. I must be using weird vocabulary because I know you guys all know that already. So if each line is worth 1, which place value are we estimating? 0.1, yes. Ooh, we get a fancy ruler this time. Ooh. Tell your partner what you think this one is going to be. What should you estimate here? All right, I am going to ask, who should I ask now? I should ask someone whose name I need to learn. So maybe I will ask Angela. What would you say is the measurement here? Sure, 6.75, because we've got 6.5, and then we have 0.6, and then we have 0.7, and it's after the 0.7, but before the 0.8, so 6.75 would be fine. Did anyone decide on anything different? Could I say 6.76? Yes, I sure could. Could I say 6.77? Sure. It's really your judgment on that last digit, okay? I mean, obviously, we're not going to say 6.71. That looks definitely not 6.71, okay? But anything in that range will get you full credit, okay? Could we say 6.755? No, because this 5 here is already estimated. Cannot go past it. The other way to look at it, what is each line on this ruler worth? This is a 0.1, right? We go from 7 to 7.1. So that distance there is 0.1 centimeters. So if we have 0.1 as our smallest line on the ruler, then we can go 1 place value more than that. And what is 1 place value more? If we have 0.1, we can go to the 0.01. Is this making sense, or am I just, yeah? Okay, good. Excellent. Okay. And if it's not making sense, you're going to come and talk to me later, yes? Okay, good. All right, you guys are going to do these yourselves. Okay? Try them, have a chat with your partner while you're doing them, and see if you agree with each other. Yeah, and do call me over if you have questions. The smallest marking. So when it says smallest marking, what that means is you're going to look and say, this one only has markings for 10 centimeters, so the smallest marking is 10. Does that make sense now? Cool. Yes. Yeah, you can. It will be fine. Either way would be fine. Yeah. Yeah. What will happen is that, as we go on, yeah. And just kind of give me a wave when you and your partners are done so I kind of know when the class is finished. Okay, can I get some answers on this one? If our smallest marking is 10 centimeters, what is our estimated digit? 1 centimeter. And so what would you say the length of the pencil is? Length of pencil is equal to 6. Yes. You could if you wanted to. We generally don't tend to. What will happen is as you go on, and if you were to go to university and study this, what we would do is we would report it as the length of the pencil is 6, equal to 6 plus or minus 1 centimeter. Okay, we're not going to go there this year just because it's another a layer of complication. If you would rather put the approximate equal sign, that's fine, but you can just put the equal sign for now. Is my answer good the way I've written it? No units. Okay, good. Excellent. So again, we have the length of the pencil equals, now our smallest marking on this ruler is 1 centimeter. Okay, we got like 1, 2, 3, 4, 5, 6, and that's it. So our estimated digit will be one position less than that, 0.1. And so the length of the centimeter would be 6.0. We're right on that line, yes? Centimeters. And then finally, when we get down here, our smallest marking is now 0.1 centimeter. So what will our estimated digit be? 0.01. So that means when we have the length of the pencil, that's going to be 6 point what? 0. And then we have to have another 0, okay? Have to have those 2 zeros because we are going to the hundredths position, right? That one is the one we're guessing at. We're not like, ooh, could it be? If we wrote 6.0, what that means is it could be 6.1 or it could be 5.9. Yes? So that would be like 5.9 or 6.1. Is anyone wondering if that is a 6.1 centimeter ruler? No, it's definitely not 6.1, okay? So, and I forgot my centimeters. Oopsie, there we go. So, summary, you can write down your little summary, see what you can remember. Okay, take a moment and do that. And then we'll talk sig figs. Anyone talking sig figs in physics right now? Maybe, yeah. Yes. I'm gonna write this with you. If I don't write it down, I'm gonna forget it again. How are we doing? We need another minute? Anyone need another minute? We're good? Okay. The one thing I wanted to say is this point here where it says, if the thing you are measuring is exactly on the line, what must you do? You must add a 0, and I would like to add to that or 2 or 3 zeros. Because it was like when we had it right on that 6 and it had the 0.1 measures, you had to actually say 6.00. So it's not just 1 0 necessarily, it depends on where those smallest measurements are. You might have to add 2 or 3 zeros, which can be a little disconcerting sometimes. You're like, where did all those zeros come from? But then there we go. Okay, so this leads us into significant figures. Anyone heard of significant figures before? Yeah? Okay. Some of us have, most of us haven't. That's to be expected. Usually you haven't when you're in grade 11 for the first time, okay? You will come across them in chemistry mostly, but they do use them in physics as well, and occasionally in biology, but not usually until later, okay? Significant, if something is significant, what does that mean to you, just in general? Significant. Important, meaningful, yes? So if we were to go back to my original goofy measurement that I made back here, you know, where was it? Oh, my 6.2489631. Which of those digits were actually important? The 6 was important and the 2 was important, right? Those are the important digits. All of the rest of them were essentially made up nonsense, yes? So you have that one certain digit here, and then you have the one uncertain digit. And both of those are meaningful. They are important. What would you say about this measurement here? The 6.75, the 6.76, and the 6.77. How many digits are meaningful there? It turns out all of them are meaningful. When we talk about meaningful digits, we mean all the ones that we are sure about plus that one that is estimated, okay? So there's all the ones that you're sure about, and then you add that one estimated one, and those are the important ones. They're all the ones you're going to actually record in your measurement, and that's what we call our significant figures. So if we are here on our next page now, so they are all the meaningful or important digits in a measurement. So it's all the digits that you know for sure, so all the known digits and one estimated digit. So if a number has 3 certain digits, how many significant figures will it have? If it has 3 certain digits, it will have 4 significant figures because there's going to be that extra estimated one. If it has 5 certain digits, how many significant figures will it have? 6, because there's that one estimated one at the end, okay? So here's our pencil again. We have 6.7. This has 2 significant figures, all right? We could, as I was saying earlier, it could be 6.7, it could be 6.6, it could be 6.8. There will be an option. I will have certain things in here that you can do if you want to. Yes? And they are not required for you to complete the course. But they will be things that you will run into in university. So I will present them to you, and this is one of the things that I'm going to present to you, and this is the uncertainty. And I'm going to put a diamond beside that because anything that is sort of beyond the scope of what is required for regular chemistry 11, I'm going to put a little black diamond beside it. If anyone has gone skiing, anyone ski or snowboard? Okay, what does a black diamond mean? It's more difficult. Okay, so it's a little bit extra. Okay, so anything that is a black diamond is optional. Okay, it's a little more difficult. But if you see this for the first time in university, you won't have spaced repetition. So there you go. Okay. So this measurement can be off by as much as 0.1 centimeters. It could be 6.7 plus 0.1, which would be 6.8, right? Or it could be 6.7 minus 0.1, which is 6.6. So when you are recording your measurements, it is an option for you, if you want to include the uncertainty. But you do not need to. You have to include the uncertainty? No. Okay? If you do choose to include it, it goes in front of the unit. Okay? The unit comes at the very end after the uncertainty. All right. So here we have this ruler. What would you say that measurement is? 6.7? Is that correct? No. Oh, what's incorrect about it? Number one, I have no units. And number two, are we uncertain about the 7? We are not. It can't be 6.8 and it can't be 6.6. We have to go one digit past that. So it would be 6.70. There is our uncertain digit. And if that is the case, how many significant figures are there in this number? There are 3. The 6 is certain, the 7 is certain, and the 0 is that extra uncertain digit. So this would have 3 significant figures. And we just start calling them sig figs because significant figures is really long to write. And for a little bit, for this unit, we're only going to be counting sig figs. Later on, we will be doing math with them because you'll be doing something like you'll be measuring the length of this and the width of this and the height of this, and those will all have a certain number of significant figures each, and we'll have to figure out how many significant figures are in your answer. But for now, we're just going to count them in our measurements. Okay. Pardon me? It does depend on what ruler you use, but it also depends on whether you have, like, let's say I had a ruler that was like this one, okay? And I had my length was 6.75 and or actually, let's call that the width. And my length was 10.42. And my height, let's say it was really, really short, 0.10 centimeters. You see how even with the same ruler, because you've got things that are smaller or larger, you can have a number. This one has 4 sig figs. And I get even lazier and sometimes just start writing SF for sig figs, okay? How many sig figs in the width? That would be 3 sig figs. And then this last one, this isn't really a number. We'll talk about zeros later. Zeros can be complicated. Okay, this one isn't really a number. It's just telling me I don't have any ones. My number hasn't started yet. Okay, and this one actually only has 2 sig figs. It's got this one certain digit and this other one that is our uncertain digit. So those are our uncertain digits. So this would have only 2 sig figs, and those are all measured with the same ruler. So it really depends on how long things are or how big they are compared with the ruler itself. To the right of the decimal, the number of decimal places is absolutely going to be consistent. Yes, that is absolutely true. Okay, so don't worry if that didn't make sense with the zeros. We will come back to the zeros later. Okay, but for now, we're just going to have some fairly nice numbers where it's like, I have a measurement. If there are 3 numbers in that measurement, I have 3 significant figures. Yep. If I've done my estimated digit right, all I have to do is count how many I have. So, if we were looking at this particular measurement, 6.70, we have our certain digits and our one uncertain digit. And if you remember, we could, if you are interested, add in the uncertainty. Hello. Good. Sorry, I stole those stands and I just put those things down and then I forgot about them. And I'm like, oops. And then I saw you bring them in here. I'm like, oh my God. Anyway, thank you, Ms. Wu. Okay. So if you want to, you can include the uncertainty. So this would be 6.70. It could be 100th higher or it could be 100th lower. Yes? Because we could end up with estimating it as 6.69 or as 6.71. All right? But like I said, that is optional. What do you think the length of this object is? Zero 0.8. Is it just 0.8? 0.8, we have to add an extra digit because I'm not wondering, is it 0.7? Is it 0.9? That's not my uncertain digit. This one here is certain. And so we have to add the extra uncertain. I cannot write uncertain digit there, okay? It is possible, you know, if I really, really zoom in super close, I'm like, oh, it looks actually not to be exactly on the line. Maybe it's 0.79. It could be, right? So the 8 is a certain digit. The 0 is an uncertain digit. How many significant figures does this number have? 2, because remember, 0's at the front. And again, we'll go into zeros in a lot more detail, but I'm mentioning it now. Zeros at the front just tell you your number hasn't started. They are not significant. Yes? You could write 80 millimeters as well. Yes, absolutely. Yeah. And if you were to write 80 millimeters, we'll get into that in a second. Yeah, 80 millimeters. We're going to learn that you would either want to put a decimal here, or you would want to say 8.0 times 10 to the 1, or you could write it as 80 with a bar over top to indicate that that's your last significant digit, but we're getting ahead of ourselves now, so I'm just not going to mention that really, okay? Yeah, we will get to that very shortly. So if we look at our measurements here, can you guys see the difference between these? No, I know I certainly can't, but when I blew them up really, really big, can you see the difference now? No? I feel like I can. I feel like this one's a little bit past the line, right? And I think this one's a little bit before the line. Let's take a look at the other one here. Let's see. Oh, yeah, it's really hard to tell. I honestly made them different. Yeah, I zoomed them, when I zoomed in, like I went on Word when I was making this document and I zoomed in like, 200 times. Those are actually different sizes, slightly. Okay, but you can't see them with the naked eye. I certainly can't see the difference with the naked eye, but there are slight little differences there. So that's why we cannot say for certain it's like 8.0, like it's just, yeah, anyway. I'm sorry, I'm babbling now. So we're gonna stop that and carry on. This uncertainty that we talk about is what is called scientific error. What do you think of when you hear the word error? You think it's wrong, you think it's bad, I made a mistake. That's not what error is in science. When we make a mistake, we call it a mistake. Okay? Error is really uncertainty. Yeah? So you have to get over that, like, you know, science sometimes changes the meaning of words. Like if you say a theory in like life, you're just meaning kind of like maybe that's a guess, right? What does a theory mean in science? You know the difference? Like if I say the theory of gravity, is anyone kind of wondering about whether gravity exists or whether it works or that we can predict how it works? Anyone kind of like gravity, maybe, maybe not? Okay. No, we're pretty sure about gravity. We're pretty sure that it behaves in predictable ways, and there's huge amounts of evidence behind it, and it is a theory. That's what a scientific theory is. It's something that actually has a lot of scientific evidence behind it, and it explains a lot of different phenomena, okay? But when we say theory in real life, I'm like, oh, I have a theory about that. My husband says, I have a theory, and it means he's just making up some nonsense because he just likes to make things up, right? So science words often have a different meaning than regular usage of the same word. So just like theory has a different meaning in science, theory is like pretty much, it's known, right? Yes, we could change it. Yes, we could make, if we discover something new, we might, you know, make a change to that theory, but it's pretty much based on the evidence we have at this point, a done deal, okay? Just like those are different words, error does not mean mistake. Error means uncertainty. So what is the error in this measurement? 0.01, because that's how far you could be off. Okay, that is how much error there is. So the more lines you have on your ruler, so if I only had one line at the beginning of the meter and one line at the end of the meter, would I have big error or small error? Big error. What if I had centimeters marked only? Smaller error. And what if I have millimeters? Even smaller error. So the more precise you get with your measuring device, the less error you have. So scientific error, it's the differences between the observed values and what is actually true in nature, because this has an actual length, right? But can I measure it that exactly? No, I can't measure it. So it's the difference between the measured value and the actual true value. And you might know that value and you might not, okay? So those are the uncertainties, and that is our error. Have we talked about scientific? We have not talked about scientific notation. Have anybody used scientific notation in the past? 1, 2, 3, 4, 5. Okay. So a few of you, we will be learning about that maybe next day because that might be handy for you to learn about, okay? But there's actually a way of rewriting this number without that decimal place in front, without the 0 in front. Do you know what 10 to the negative 1 means? 10 to the negative 1 is deci, yeah, and it is 1 over 10. So it's 1 over 10 to the 1. Okay? So we could rewrite 0.80 as 8.0 times 1/10. Would that be correct? Yeah? 0.8 is equal to 8 times 1/10. Yeah? And so you can see that when we do that, that would be same as writing 8.0 times 10 to the negative 1. What happened to this 0 here? It just yeah, it disappears because it's not significant. That's why those zeros are not significant, because if you rewrite it in scientific notation, it goes away. So zeros on the left, are they significant? No. Zeros at the beginning on the left are called leading zeros. So we have leading zeros are on the left, and they should be left out. Okay, zeros on the left should be left out when you are counting sig figs. Okay, leading zeros are not significant. Nope, nope, nope. So how many significant figures in this number? 3 sig figs, 3 significant figures. Those leading zeros only tell you that your number hasn't started yet. Okay? Now, this class is over in what, 5 minutes? Something like that? I gotta learn my new times. 1:50. Okay, so you know what? I feel like you all are dying because I've been talking for like forever. Am I right? Yes. Okay. Do you want to just try this one? Do it on your own. There you go. Example 5. Do example 5 on your own. Oh, I think it is in the answer key. Let me just check. Make sure it is. That is 1.4. Yeah, it says, oh, maybe not that one. Let's see. Yeah, filled in. Okay, so it says 1.4c filled in, and yeah, so it's right there in the answer key. Yeah, cool beans. Yeah, so you would say 60. That 0 at the end. Yeah. Is this question making you think? Is it making your brain want to explode a little bit? So what if, this first one is not so bad, right? What was the first one? Were we sure about the 6? Yeah. Are we sure about the 0? No, we're not sure about the 0. It could be 61 milliliters or whatever. So we could say this is 60 milliliters. And I am going to put a bar over that. And that tells me that this is my, or sorry, I should write that as a this. This is my estimated digit. only use it for zeros because sometimes zeros are estimated and sometimes zeros are not estimated. We never put a bar over a 1. So if I said 61, I would not need to put a bar over it because the 1 is my last digit. It would therefore be my estimated digit. Final digit is, but when you look at that 0, you're like, is that my estimated digit? Here it is. What about this other one over here? Are you sure about the 6? No. And that means if you're not sure about the 6, could you be sure about the 0? No. So we still have, our measurement is still probably 60 milliliters. Is that 0 our estimated digit? No. This one here is our estimated digit. So that 0 at the end is only telling us that we don't have 6, we have 60. Yes, we're not like, ooh, is it 6 or is it 7? It's like, ooh, is it 60 or is it 70? Okay. So in this one, we have our certain digit and we have our estimated digit. In this one, we only have an estimated digit. There are no certain digits. So your sig figs are all the certain digits plus that one uncertain digit. So in this case, how many sig figs in this number? 2. 1 certain and 1 uncertain. How many sig figs in this number? 1 sig fig. There's only 1 digit. There's no certain digits. There's no certain digits and there's 1 estimated digit. But they look the same, right? They look the same. How frustrating is that? And we're running out of time today, but next day we will get into the fact that you would write 60. If that digit is estimated, you would write it either like that, or if you stick a decimal in a number, it automatically means that 0 is significant, okay? Or you could write it as 7, 6.0 times 10 to the 1. And like I said, we'll talk more about that next day. The other one would simply be written as 60 or 6 times 10 to the 1. Okay, but we'll talk more about that next day. For your homework, what I would like you to do is I would like you to watch Solutions Video 1. So that is page 41. So do 1.3a. There we go. And the other thing I would like you to do is I would like you to try 1.2b. This will be on Teams. Okay, so that will be on Teams. So there's a short video, and then this is a review of accuracy and precision. Okay?